want to show you how to graph a linear equation using a table of values. So the equation that I'm beginning with is y is equal to negative 1/3 x plus 4. If I'm using a table of values, I'm going to have to choose 3 input values for my independent variable. Some values are easier to work with than others. For me personally, I like working with whole numbers, and I see that I have negative 1/3 times x. So if I like whole numbers when I'm graphing, I'm going to have to choose numbers that are easily divisible by 3. So I choose negative 3, 0, and 3. For each input value, I'm going to substitute that value in for my variable x, and then simply use order of operations to calculate what my output value is, y. I must multiply first. So I'm at negative 3, 5. Negative 1/3 times 0 is 0. Okay, so I substituted each input value into my original equation and calculated what my output value for my variable y is going to be. Each solution, each pair of coordinates becomes an ordered pair or a point on my graph. So I'm creating a graph of all of these solutions. I have 3. Here we go. So each tick mark here counts as 2. So here's negative 2. Negative 3 would be about here. And then positive 5. So 2, 4, 5. My point will be right here. 0, 4, 0, 2, 4. And 3. And 3, 3. So 2, 3, 2, 3. So these 3 points represent 3 solutions to this equation. There are infinitely many solutions. However, all of them lie on a straight line. As you can see, the 3 points that I've plotted form a perfectly straight line. So to graph the rest of the solutions, I simply need to follow the pattern. There we have it. I have another problem for you. 6x minus 5y is equal to 20. Unlike the first problem we worked with, this equation is not already solved for y. So I'm going to subtract 6x on both sides to begin that process. I want to isolate y on one side of the equation. It makes it easier to work with input and output values. So 6x minus 6x is equal to 0. That leaves me with negative 5y on the left-hand side. On the right-hand side, I like writing my variable terms first. So I'm going to bring down the minus 6x. So I get negative 6x. It's a positive 20, so I'm going to write plus 20. From here, there's a negative 5 being multiplied by that y. I want to undo that happening, so I'm going to divide by negative 5 on both sides. If you've seen my previous video about solving for y, you'll understand why I'm giving each term on the right-hand side its own division. I'm going to distribute that to make it easier to simplify. So negative 5 divided by negative 5 is 1. So I bring down my y. That's all I'm left with there. On this other side, I have negative 6 over negative 5. That will be positive 6/5. Bring the x along with it. And I have positive 20 divided by negative 5. That's negative 4. So I'm going to write minus 4. Now that I've solved for y, I can begin picking my values. Now I notice the denominator of this fraction is a 5. So I'm going to pick numbers that are easily divisible by 5. Negative 5, 0, and 5. So just like the last problem, I'm going to, one at a time, take each input value and substitute it into my equation to see what I get for my output, my y. Okay, so for each x value, I've substituted into the equation and then use order of operations to figure out my y value. So I have 3 ordered pairs that are all set and ready to go. So I need to plot each point one at a time. 5, negative 10. As we can see, those 3 ordered pairs form a perfectly straight line. So to finish graphing, I need to represent the rest of my solutions. So I'm going to connect them with a straight line. We'll make that extend all the way across the coordinate plane, so there's no guessing as to where the solutions are.